Hello, and welcome to 5-Minute Math. Today we are looking at the 4th grade concept of classifying two-dimensional shapes. This is standard 4.6D in the great state of Texas, and we are using item number 20 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So Landry drew a flag with exactly one pair of perpendicular sides. So exactly, not at least, exactly one pair of perpendicular sides. And then which of these could be the shape? All right. Well, let's first see what this means, this perpendicular. That is a very large term. And perpendicular sides or perpendicular lines form when you have lines that make and there's a few different ways we can say this, 90-degree angle. We can also call this a right angle. So the right angle is the name of the angle, the 90 degrees is the measure of the angle. Or, quite honestly, easiest way for me to always think of it is a square corner. So it looks like this. And you see how that looks kind of like the corner of a square. And sometimes we'll even put a little square inside there to show that it is exactly 90 degrees. And so perpendicular lines actually have a symbol in geometry. So when you say that two lines are perpendicular, you put an upside down capital T in between them, and it shows that they form that right angle. So which of these, right triangle, acute triangle, rectangle, square, has exactly one pair of perpendicular sides? So let's start with F, our right triangle. All right, so a triangle's got three sides. A right triangle, kind of put that right there. And there's many different right triangles. You could draw some right triangles that have the same side lengths. That's going to be isosceles. This one is a little bit more with its three different side lengths. That's more scalene, but either way, we have a right triangle, and it's got one pair of perpendicular sides. If I'm going to label the sides as 1, 2, and 3, I could say that side 1 is perpendicular to side 2 because it makes that little right angle. So that's pretty good. And I kind of like F. Let's see what G's got here. An acute triangle. I'm not sure. There's a whole bunch of different types of acute triangles. I could kind of do one like that. It's a little bit more isosceles rather than equilateral. Either way, though, I don't see any 90-degree angles. What makes an acute triangle an acute triangle is all three angles are acute. That's why it's called an acute triangle. Are less than 90, less than that 90 degrees. So that is definitely not going to be it. So we know what a rectangle and a square look like. So let me put my rectangle right here. We'll kind of do that same thing to where I will label the sides 1, 2, 3, and 4. And look at, we've got all four of these are square corners. They all have 90 degrees. There's actually four angles, and they're all right. So I could say that side 1 is perpendicular to side 2. Side 2 is perpendicular to side 3. Side 3 is perpendicular to side 4. And then back to side 4 is perpendicular to side 1. So that's not going to work. We've got four pairs of perpendicular sides. Each one of these sides is perpendicular to the one it touches. So that is not going to work either. Let's check my square. And if you know anything about squares, you know that all squares are actually rectangles, which means if our rectangle's got four pairs of perpendicular sides, you know our square is going to have the same. And we can say that side 1 here, perpendicular to side 2. Side 2 is perpendicular to side 3. And so on. 3 is to 4, and 4 is to 1. So those have perpendicular sides, but we want exactly 1. So that only leaves us with F.